Hello everyone, this is BUK working as an assistant professor of physics in Dr. BRR Government College, Jechal. In our last video, we started the chapter Digital Electronics and we tried to understand the basic terminology and the definitions that we come across in this chapter in our last video itself, and also in our last video we tried to understand the uh, different number systems that do exist, and also we tried to understand in detail what is the decimal number system and how do we write the decimal number systems with by that means by following a logic. uh, Anyway, in today's video, we completely concentrate on the binary number system. Okay, we try to understand what is a binary number system and how do we write the binary numbers in terms of the equivalent decimal numbers, and also we try to understand how do we convert the decimal number into binary and the binary number into decimal. So this is what we are going in today's we are going to deal in today's video lesson. Okay, now okay, so binary number system. So you know that binary number system is a number system which consists only two digits. So you know this one, right? So this system, the binary number system, contains only two digits which are 0 and 1. So you know this one, right? And since the basic symbols are the digits that this binary number system has only two, which is 0 and 1, its base becomes 2. So this also known to you because we discussed in our last video. So to represent any number, we only use the 0 and 1 in case of binary number system. So you know that in case of decimal number systems, we were having 10 digits, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But in case of binary number system, there are only two digits, 0 and 1. So whatever may be the number, for example, let us take 99 in case of decimal system. In case of decimal system, 99. So that 99 is also represented only in terms of zeros and 1 if you write that 99 in case of binary number system. So whatever may be the number, that number is only represented in terms of two digits which are 0 and 1. So this is called as binary number system. Anyway, how the binary equivalent of some decimal numbers are written, that you can understand with the help of this table. So it is the table which gives the equivalent decimal numbers in terms of binary numbers, so that you try to understand. For example, in decimal system 15, this is written in binary number system by 4 ones, double one, so that you try to understand. Similarly, if you take 22, which is a decimal number, remember there is no such symbol 2 in case of binary. but there is a symbol 2 in case of decimal. So please check it out. If there is a number which consists 2, 3, 4 and so on, it's not a binary. If it consists only 0 or 1, then only we call it as binary number system, otherwise it will be some other number system. Okay. Anyway, if I take the example of 22, in binary number system, this 22 is written as 10110. So that is what you have to understand. Anyway, let us try to understand how we have written these numbers first of all. Anyway, in our last video, I hope it is clear how we write the decimal number systems by using the logic of combinations, possible combinations, right? By using the same technique, you can write all the binary number systems that I have written over in this slide. So anyway, let us try to understand how the binary number systems are written over here. Okay. So for that convenience, I just take the pointer now. Okay, so you know that there are 2 digits only in binary number systems. What are they? 0 and 1. So how we have written decimal numbers, I hope you remember them. What we have done, we have taken the smallest number, smallest digit or smallest basic symbol in that decimal number system, which is 0, and we have written all the possible combinations with that. Okay, so that same thing we do here. So we take 0 now. If I take 0, the possible combinations that you get with 0 are 0 0 and 0 1. These are the possible combinations that you get. So this 0 0 I can write it as just 0, and 0 1 is also I can write it as just 1. So it's the binary conversion. Remember, the binary and the decimal equivalent I am trying to show in this table. Okay, so please check it. So this 0 0, this 0 0 and 0 1 I am writing down here. So please check it out. And this is a decimal number. That means in case of decimal number, a 0 is written as 0 even in binary number system. Similarly, in case of decimal number system, 1 is written as 1 itself even in case of binary number system. So only 0 and 1 are same in case of decimal and binary number system. Other numbers will be different, so please check this. Okay. Anyway, now let us take the decimal numbers system, which is 2. So now 2 I can write it as 1 0. So how do we write this 1 0? So that you try to understand. So now 0 combinations are over here, right? So I have written the possible combinations of 0, which we got it as 0 and 1. Now take 1 now. Now take 1. So now the possible combinations of 1 will be 1 0 and 1 1. And you know that in case of decimal number system, after 1 what do you get? You get 2, right? And after 2 what do you get? You get 3. So that is what you get here. So in case of decimal, 0 will be written as 0 in binary. In case of decimal, 1, and in case of binary will be written by 1 only. And in case of decimal, 2 is written as 1 0 in case of binary. Okay, so please check it out. The decimal 2 is written as 1 0 in terms of binary, and 3 is written as 1 1. So that you have to understand here, which I have written over here. So these are the 4 combinations that you get with 0 and 1. So now the possible combinations are over with 0 and 1, right? So let me take some other pointer. If I take some other pointer, what I get? So for example, okay, let me take this. So now 0 combinations I have written. One is 0 0 and 0 1. These are over, right? These 2 are written here. And the next, what are these 2? These are 1 0 and 1 1 combinations I have written over here. So these 4 combinations you get from 0 and 1 possible combination. So that means If I just round it off, uh, so the zero combinations are over. The zero combinations are over, right? Which you get it as 0 0 and 0 1, right? And even the one combinations are over, okay? Which we got it as 1 0 and 1 1. And what will be the next digit in this table? So please check it out. In this table, 0 combinations are over, 1 combinations are over. Now the combinations will be starting from 1 0. So that means 1 0 0 and 1 0 1 will be our next combinations. Okay, so once 1 0 combinations are over, what you have to do, you the combinations with 1 1 will automatically start over. So if I write 1 1 combinations as 1 1 0 and 1 1 1, so these two combinations that you get, and the next combination start from this one is over, right? Now the next combinations will start from 1 0 0 0 and what do you get? 1 0 0 1. So this is these are the two numbers that you get from 1 0 0. Next combinations will be what? 1 0 1 0. This is written over here, please check it out. And the next 1 0 1 1. So these are the combinations that you get, and next combinations will start from 1 1 0 now. So 1 1 0 0 and 1 1 0 1. So here you can see 1 1 0 0 and 1 1 0 1, and the next number will be what? Triple 1. So triple 1 will have two combinations again, triple 1 0 and triple 1 1. So where do you see them? Here, triple 1 0 and triple 1 1, and so on it continues. And the next number will be 1 0 0 0 1 0 0 0 and 1 0 0 1. So these two combinations that you get from 1 0 0, and the next one 1 0 0 1. Here you can see 1 0 0 1 and 1 0 0 1, and the possible combinations are 0 and 1, and like that this chain process continues. It continues. So that means from whatever the numbers that you already have written, and from those numbers you keep on writing the possible combinations. If you keep on writing, so you get the decimal equivalent numbers. Okay, so if I try to compare the decimal numbers with the binary numbers, I can write the decimal 0 as binary 0, decimal 1 as binary 1. They are same, they are looking same, but 2 I can write it as 1 0 in case of binary, and 3 I can write it as 1 1, 4 I can write it as 1 0 0, 5 I can write it as 1 0 1, 6 I can write it as 1 1 0, 7 I can write it as 1 1 1, 8 I can write it as 1 0 0, 9 I can write it as 1 0 0 1, 10 I can write it as 1 0 1 0, and so on it continues. Okay, so 1 0 0 1 combinations are over, right? Next, what combinations you start? 1 0 1 0 combinations are starting here, so please check it out. 1 0 1 0, 1 0 1 0 0, 1 0 1 0 1. Next 1 0 1 combinations will start. So each number that you are writing here, that number you will be writing from a number which you already got. Okay, so you are just keeping on writing the possible combinations in an increasing order. Okay, so that is what you do. So if you keep on doing that, you can write any binary number that you want. Okay, but this procedure is going to be very difficult. So the decimal for example, if suddenly if I ask you to write the decimal 110 in terms of binary, it is going to be very difficult to you, right? For example, if I want you to write 999 in binary number, how do you write? You can't write all the possible combinations like this, right? So there must be a method by using which you can write the binary number or the decimal number into binary very quickly. There must be a technique. Okay, so by using which you should be able to write the decimal number into binary. Okay, so that of course there is a technique by using which you can convert binary number into decimal, and the decimal number into binary very quickly. And what is that technique, that we will discuss in our next slide. Okay, so this is our next topic, which is the conversion of decimal into binary. So how do we convert the decimal number into binary? So this is what we are going to discuss now. So a decimal number can be converted into binary by a double dabble method. So there is a method, a technique, which we call it as double dabble method, using which you can convert a decimal number into binary. So what do we do in this double dabble method? Okay, so that you try to understand. This question is very important for your board examinations, or even competitive examinations, so you need to remember this technique. Okay, so in this technique what we do is that it is the most practical, popular and fast method. Which one? Double dabble method. So in this method the decimal number is divided by 2. So please check it out. Here what we are doing, we are dividing the decimal number by 2, writing down the remainder. So whenever you divide the decimal number with 2, there will be some a remainder that you get, and that remainder is written on its side. Okay, writing down the remainder after each division. So whatever that means, in each steps of division, whatever the remainder that you get, that remainder is written on its side itself. Okay, okay, so this is where you write the remainder. Okay, and the remainders taken in reverse order gives the binary number. So whatever the remainders that you are writing down after each division on its side, that remainders taken in reverse order gives the binary number. So this is called as double dabble method. So please check it out. So here what you are doing, if any number, any decimal number, when it is given to you, you can easily convert it into binary. So for that you have to follow this double dabble method, in which we divide the given decimal number with 2, writing down its remainder. Okay, you write its remainder on its side after each division, and once the division is over, complete, whatever the remainders that you get here, that is taken in reverse order. So if you take it in reverse order, that number gives you the binary number, okay, which is converted from the given decimal number. So that you try to understand. Okay, anyway, the steps are discussed in this paragraph. Now let us try to solve a few problems in which we convert a decimal number into binary. Okay, for that let me take a marker now. So let us assume that this is our first example, in which what is given over here. So we have to convert a decimal 11. This is not binary. If it is binary, it is pronunciated as 1 but since it is mentioned decimal here, it is nothing but 11, right? So the decimal 11 into binary. So now our aim is to convert 11 into binary. So this is our first question. So how do we convert it? We use this double dabble method. So this we use this double dabble method to convert this decimal number into binary. So what is this double dabble method? You have to just divide with 2 and writing down the remainder after each division on its side, and taken that remainders in reverse order gives you the binary number. So this is what discussed in double dabble method, right? Okay, so let us try to find. So this is 11, which we want to convert into binary. So for that what we do, we just divide it with 2 now. So let me take so anyway it is written over here if you want, but let me solve it for your convenience here. So I am just taking 11 now. So what you do is that you just divide it with now. So you know that 2 5s are how much? You get 10, right? 2 5s are how much? You get 10. Okay. So what will be the remainder here that you get? You get 1 here. That's it. For example, if you want, I will solve this in this way also. 2 5s are how much? You get 10. So 11 minus 10 becomes how much? 1. So this is what you get. And again you have to divide this 5 now. So if I divide it with 5, what do you get? So this is 5, right? So 2 2s are 4. 2 2s are 4. So and 5 minus 4 gives you how much? Again 1. This is what you get. And again what is left over here? 2 is left. So again divide this 2 with 2. So if I divide it, you get 2 1s are 2. So that means you get 2 minus 2 is how much? 0. So this is remainder. So that I am writing. This is remainder. Okay. So what is the remainder things on after each division that I am getting? I am getting 1, 1 and 0 and so on. Okay. And the next, what is 1 here? And remember, since 1 is less than 2, you can write that 1 here itself directly. You can write it here itself. Otherwise, you can also divide it with 2. So how do we divide 1 with 2? You just divide it with 1 with 2 by this way. 2 zeros are 0. That means 1 minus 0 I can write as 1. So these are the remainders, and these remainders has to be taken in reverse order. If I take it in reverse order, you get 1 first, next 0, next 1 and next 1. So that means 11 I can write it in terms of binary as 1 0 1 1. So since it is binary, it is written, that means whatever the number that you get, that is written in the bracket. And there are different types of number systems, you know that. Since we are converting the decimal number, since it's a decimal number, right, and its base is 10, you already know that, and hence that base is mentioned here along with the brackets. Okay. Similarly, since we are converting a decimal number into binary, and binary has a basic base, not basic, base, has a base of 2, and hence that 2 is mentioned over here. So that you have to understand. If you don't mention this 2, what happens? There is a chance that we may get confused here. We may think that this is 1011, but actually it is not 1011, it is just 11. Okay. So if you don't mention this 10 or 2 along with the brackets, you get confused with the number system that has been given or written. Okay. So whatever it may be, you have to be very careful while understanding what number they have given to you and how you have written it. Okay. So that you have to understand. Anyway, let us take one more example. Let us try to convert 13 into binary. So to convert 13 into binary, you already know the procedure. Okay, for convenience I am doing it here. So let me take 13 now. Just for convenience I am doing it here, so that it will help you. So you have to divide it with 2. If I divide it with 2, you get what? 2 6s are 12. And the remainder will be how much? 1. So this is remainder. So please check it. Actually in examination you need not write minus 12 and all those things, but for your convenience and understanding I am doing it. In your final examination, if you write even this thing, it is sufficient to you. But how you got that, I am solving it here on left hand side. Okay. And then next again you have to divide it with 2. So if you divide it with 2, what you get? 2 3s are, that will be equal to 6, and the remainder will be 0 again. Okay. Again you have to divide it with 2. So you know that it is 2 1s are 2, and hence 3 minus 2 will be equal to 1. So you can stop here itself. Okay. If you stop here, what happens? This 1 will come here. This one will come here. Otherwise, if you don't want to stop here, even you can divide it you can divide this with 2. So how do you get? You get 2 zeros are 0, that means 1 minus 0 will be equal to 1. Okay, so this is how you get. So these are the remainders that I got: 1 0 1 1, but this remainders has to be taken in reverse order. So since it has to be taken in reverse order, what do you get? You get 1 1 0 1. Okay, so what do we have here? 1 1 0 1. So 1 1 0 1, since it is a that means a binary number, it is represented with 2 here, so that you try to understand. Similarly, let us try to solve one more number here, and that is 100 to the base 10. So 100 to the base 10 also can be converted into binary, and for that the procedure is written over here. So please check it out. 100 has to be divided with 2. Okay, so if I do so, what you get? You get 250 is 100, so that means 100 minus 100 will be equal to 0. I will try to solve it here itself. So 2 into 50 is 100, right? So 100 minus 100 will be equal to how much? 0. Similarly, 225 is 50, you know that, so that means 50 minus 50 will be 0 here, but here onwards you get ones. So 2 12s are 24. Okay, so that means 25 minus 4 is 1, and the next here you have 12. So 2 6 are 12, so that means 12 minus 2 will be 0. And what do you have here? 6. Now you have 6 here, right? So 2 3s are how much? 6, and 6 minus 6 will be 0, and again you have 3 here. So 2 1s are 2, so that means 3 minus 2 will be equal to 1. Is that clear? So since you got 1 here, you can stop here itself, otherwise you can again divide it with 2. So if you divide it with 2, since it is less than 1, 2 zeros are 0, and that means I can write here it as a 0. So 1 minus 0 becomes 1. So this is the binary number that you get, and remember this remainder has to be taken in reverse order. So since you have to take it in reverse order, what do you get? 1 1 0 0, 1 1 0 0, and 1 0 0. So that is what you get. So this is the binary number that is converted. Okay, so I hope it is clear to you. So let us move on to our next thing. So anyway, till now you have converted a decimal number into binary, which is greater than 1, which is not a fraction. Okay, now what we do is that we try to convert a decimal fraction into binary, okay, which also will be a fraction. So our aim is to convert a decimal fraction into binary fraction. So that is what we are going to do now. Okay, so that we try to understand how to convert that. So anyway, a decimal fraction is converted into binary by multiplying the number continuously by 2. In our previous slides, what we have done, we try to convert a decimal number into binary. While doing that, we have followed the double-double method, right? In double-double method, what we have done is that we have divided the given decimal number with 2 and writing down its remainder on its side, and finally taking that remainder in reverse order. That is what we have done. But here, in case of fraction, you should not divide the decimal fraction that is given to you, rather you have to multiply with 2. So that is quite opposite to the conversion that we already have dealt in our previous slides. Okay, so here in this case, a fraction, if there is a decimal fraction given it to you, you should not divide it, rather you have to multiply with the 2. That you try to understand. Okay, so that means whatever the number or fraction that is being given to you, you have to multiply it with 2. So after multiplying it with 2 on each step, okay, you have to write the carry in the integer position, or you have to write the carry on its side after multiplying that fraction with 2, whatever the carry that you get. Carry is known to you, right? I hope you know what is carry. For example, forget about binary for a second. Decimal number system, right? If you add 9 and 2, what happens? You get 11. And out of 11, what you do, below 9 and 2, you just only write one, and another one is given to the next higher order column, right? So that we call it as carry. Carry is the digit that has been given to the higher order column. So that is called as carry. So here also we are speaking about carry. So whatever the fraction that has been given it to you, to convert it into binary fraction, you have to multiply with 2, and whatever the carry that you get, that has to be written on its side. Okay, so that you have to understand. So anyway, after writing down the carry, okay, whatever, so this is carry. So after each multiplication, whatever the carry that we get, we write it down on its side itself, and whatever the carries that we are getting here, that are taken in a downward direction, which gives you the binary fraction. So this is the technique that we have to follow in order to convert a decimal fraction into binary fraction. Okay, so to understand this, we will solve a few examples here. Okay, so let us take the first example now. Let us try to convert 0.5 to the base 10. To the base 10 tells you that it's a binary fraction. Sorry, it's a decimal fraction. It's a decimal fraction. So now they won't say convert it into binary fraction or decimal fraction, all those things. They will not give the question in detail sometimes. You have to understand that it's a decimal fraction. Okay. So how do you understand that it's a decimal fraction? By saying this 10 here, you can say that it's a decimal fraction. So how do we convert this 0.5 to the base 10 into binary? So you know that while converting a decimal fraction into binary, you just have to multiply this with 2, that's all. So now 0.5 is multiplied with 2. What are you getting here? You are getting 1.00. Where this 1 is greater than 1 cases, greater than 1 cases, it becomes the greater than 1, and hence this 1 becomes carry now. Okay, and hence after removing this 1, which moves on to the column of carry, what will be left here? There will not be anything here, and hence you can write it as 0.00 with a carry of 1. Okay, and hence this 0.5 to the base 10, I can write it as, what have I got here? I got a carry of 1, right? So that carry of 1 is written after the decimal fraction, that's all. Okay, so but this is now called as binary fraction. So 0.5 to the base 10 is written as 0.1. Where do you get this 1? This 1 is nothing but the one that we get from carry, the column of carry. So that you try to understand. Okay, so that's it. Anyway, let us try to understand the decimal fraction conversion into binary fraction by taking another example. And what is that example? This example is going to be very useful to you because it gives the clear understanding of how we convert the decimal fraction into binary. Anyway, let us take this one, 0.4375. And I want this 0.4375 to be base 10. I just want to convert it into binary. So to do that, what we do, we just multiply with 2 now. Where is that? Here. So 0.4375 into 2, how much I get? I write it on left hand side for your convenience. So this becomes 1.8750. If you want, you can check it. 2 5s are 10. Okay, and the next 2 7s are 14, plus 1 becomes 15, that means 5. And the next 2 3s are 6, plus 1 7. And the next what else I get here? 2 4s are okay, There is something wrong here. Mm, okay, fine, that's it. 2 fours are 8. Sorry, I have written here, I have written wrongly here. Actually, it is not 1.8750, this is 0.8750. Okay, so this is 0.8750, that is what we get. So 2 fours are 8. So that means, let me take arrow here. 2 fives are 10, and 2 sevens are 14 plus 1 15, and 2 threes are 6 plus 1 7, and 2 fours are 8, and 2 zeros are 0. So that means 0.8750 is the value that you get here. So this 0.8750 I can write it. Remember, that means before this decimal fraction, we have 0 only. That means carry will be 0. So that you try to get it. Next, whatever you get, that will be again multiplied with 0.875. So when you multiply this 0.875 with 2, now the value will be greater than 1, and its value will be how much? 1.750. This is already solved value, so please check it out. Anyway, if you want to check it, you can check it. Okay, so how do we check it? 2 fives are 10. Okay, so 1 is carry, 1 becomes carry, and 2 sevens are 14 plus 1, which was carry, that becomes 15. So 1 is carry over there. Okay, and the next 2 eights are how much? 16, and 1 is carry there, right? So 17. So here 3 digits are there after decimal point, and hence you get 1.750 here. This is what you get. So this is 1.750. Okay, so this I can write it as 1 plus 0.75. This is how I can write. So now this one becomes carry. So now since whatever the carry, which is 1 I got, it is separated out. So please check it out. Since 1 is carried out, what will be left? It will be only 0.75 will be left. So that 0.75 is written over here. And again, that 0.75 has to be multiplied with 2. If it is multiplied with 2, what do you get? You get 1.500. You can check it out. Okay. So this 1.500 will be again splitted in terms of carry and the fraction. This one will move on to carry, and the remaining part will be written as it is, 0.500. And again this 0.500 has to be multiplied with 2. And now what happens? You get 1.000. That means if this 1 is moved to carry, what will be left? There will not be anything which is there to multiply in our next step, and hence the process is over. So that means whatever the decimal fraction that is given to us, that is completely converted into a binary fraction. But before writing it down, you must remember the order in which the carries has to be taken. Okay, so anyway, this is what given to us, 0.4375 to the base 10 is equal to, so since it's a fraction, so first of all put a fraction there, 0 point, you have to write it down first, and then next, what are the values that you got in case of carries? You write them in descending order. Descending in means from upper carry to lower carry, you have to write it down. That means you have to read the carries in downward direction. So if you do so, you get 0 1 1 1, 0 1 1. So that is what you get here. So anyway, similarly you can convert. So what we have done up to now, we have converted a decimal number into binary number, and also a decimal fraction into binary fraction. Sometimes what happens is that in your problem there will be a decimal number and also a fraction. So both will be there. Remember, while converting the decimal number which is greater than 1, you have to use double method. Okay, and while converting the fraction, you have to use the other method of multiplying with 2 and writing down the carry on its side and taking it in downward direction. So that means you have to do it separately. So here 10.75 means what? It's a decimal number whose value is greater than 1. So that means here 10 shows you that it's an integer, and that can be converted with the help of double double method, and 0.75 will be a fraction. That also can be converted separately by multiplying with 2 and writing down its carry on its side and taking it in downward direction. So that means when the problems are given in such a way that it consists decimal number and also a fraction, you have to do them separately. For example, you can see here. So out of 10.75, first 10 has to be converted into binary by using double double method. Next, 0.75 is converted into binary fraction by multiplying it with 2 and taking carry on its side. So that you have to understand here. Okay, so anyway, this problem, if needed, we will deal in our next video, and in our next video we also try to convert the binary into decimal. So you know that how a decimal can be converted into binary, that we discussed today, right? Similarly, in our next video we will try to convert the binary into decimal. Okay. I hope whatever we discussed today, they are clear to you, and we will meet in our next video. Okay, thank you once again.